Hello, and welcome to today's lesson where we're going to find some critical information from the different types of quadratic formulas that we have using our algebraic tools. So using some of our algebra procedures to find the critical values for the different types of quadratic functions. Now, when we're looking at graphs, we have to understand that there are three different forms for any quadratic. We can have vertex form, we can have standard form, and we can have factored form. Each one of these forms gives us certain information in a lot easier of a format. So when we're looking at vertex form, okay, vertex form based on its name gives us the vertex value. The vertex value is always the opposite of the inside value with the x, and then the outside value is our y, and we trust the y. So we don't trust x, we do trust y, and that helps us build our vertex. Okay, now, standard form, the best thing that we can get from standard form is our y-intercept. Remember, your y-intercept happens when x equals 0. So if I'm plugging in a 0 for x, we lose this piece, and we see our y-intercept is -9. Now, factored form. Factored form is very good for giving us our x-intercepts. X-intercepts happen when the equation or the y equals 0. So we're finding these points, and our x-intercepts come from factored form. When we take each factor that we're given, we set the factor equal to 0, and we solve for x. Same thing in this situation here. We take the factor, set it equal to 0, solve for x, and now we have our two x-intercepts. So we have an x-intercept here at +5, and I don't know why I was writing a 3 for that equation, so let's get this in the proper form. X plus 3 equals 0, x equals -3. I wrote a 5 again. I don't know why I'm into the 5s today. Okay, so we have a -3 for our other intercept. Now, what we're trying to find here, though, is the axis of symmetry. The axis of symmetry is a vertical line, so it's an up-down line, x equals equation, which is the center of the graph. Now, the center of the graph will come to us in different forms when we're looking at these equations. Vertex form, that's our best case scenario. So our axis of symmetry is going to be x equals 7, because the 7 is the central point of that graph in terms of x. Okay, now, our second easiest form to find the axis of symmetry is factored form. So when we have our x-intercepts, the axis of symmetry, okay, which is x equals, this value is going to be the value that's directly in between the two intercepts. So if we're trying to find that value, what we're going to do is we're going to average or find the midpoint of the two intercepts. So we add the x-intercepts together, divide by 2, and we get our axis of symmetry in this situation of 2 divided by 2, or 1. Now, the hardest form to get your axis of symmetry from is standard form. Now, you have a couple options. You could take from standard form, you could try to factor it and then use your factors to find your axis of symmetry, but we can actually take something from the quadratic formula and find our axis of symmetry. So the quadratic formula is minus b plus or minus the square root of 4a, or b squared minus 4ac, all over 2a. But when we're looking at this equation really has two parts to it. it has the front part, and then it has the plus or minus portion, which also ends up using the 2a as well. But if we look at this front part of the equation, that is where we start our middle value from and stretch out from both directions to find our intercepts. So what we can do is we can use this front part of the value to find our axis of symmetry. And we just use the minus b over 2a. So we have our axis of symmetry in this situation. Okay, our AOS, axis of symmetry, is minus b, negative 4, over 2 times our a leading value of 2. So we have negative 4 over 4. Our axis of symmetry is negative 1. So now, those are the three types, the three ways that we can find the axis of symmetry. So now, let's look at a few extra examples. And what we're going to do is we're going to try to identify, and work from our easiest ones to our more difficult. So what we look at here is we've got a vertex form, and we even have a, that one looks like it's vertex form down here, but that one's actually factored form. Okay, it's not vertex because of the two separate x's. We don't have a squared term. Okay, so that one is factored. Then we have a standard form, and factored form. Okay, so we have two of each. Let's start with vertex. Vertex is the easiest way to find your axis of symmetry. So we have x equals, and remember, it's just the opposite of the inside value. So in this case, it is a negative 6. Okay, we look at our vertex here for our second vertex form. We've got a negative 4. So our axis of symmetry is x equals positive 4, the opposite of the inside value. Okay, so those are our easiest ones for finding the axis of symmetry. Now, our next easiest type, going to factored form. Remember, we have to find our intercepts first, set equal to 0. Okay, a lot of times it's going to be easy, but once in a while there'll be a fraction thrown in there, and you have to be careful with that. X equals negative 10 for the intercept, and x equals negative 8 for the intercept. Okay, so remember, that's what we found here, is we found the x-intercepts for this graph. So for our axis of symmetry, all we have to do is average those two intercept values. Negative 10 plus negative 8 divided by 2, negative 18 divided by 2, or an axis of symmetry of negative 9. Okay, we've got our second factored form. This one is always the easiest factor to miss. We set it equal to 0 and it's done. So now we've got our next one, x plus 4 equals 0, x equals negative 4. Okay, and remember, what we've done here is we found our x-intercepts. And once we find our x-intercepts, then we can find our axis of symmetry by adding the two values and finding their average, dividing by 2. So our axis of symmetry here, negative 4 over 2, or a negative 2 value. Okay, now the last two that we have left are standard form. We'll only make those kind of stand out. We'll change some color here to help with that. Okay, remember, could we factor and use the x-intercepts to find your axis of symmetry? Yes, that's something that you could do. But remember, we have our equation that comes from the quadratic formula that can help us with that, our minus b over 2a. And we can just pull the values out to do that solution. So we've got minus 5 over 2 times 1, okay, or a negative 5 halves for that axis of symmetry. Okay, so that one isn't even a perfect point, which can happen at times as well. So now, our next axis of symmetry up here, okay, x equals minus b, so we have minus a negative 10 over 2 times our a value, minus 3. So we've got two negatives on top. It becomes a positive 10. We have a negative 6 on the bottom, and then we want to simplify whenever possible. We can divide both of those by 2, and we get a 5/3. And even though the negative sign is on the bottom originally, okay, it always goes out in front of the value when we're finishing. Okay, so that's one of our main steps today. How can we go through and find the axis of symmetry? Now, a couple other pieces that we have. How can we find the vertex? Okay, axis of symmetry is one critical value. Vertex is another critical value. The vertex really helps us with the range of a function. So when we're talking about domain and range, the good news is since these are all parabolas, the domain is always negative infinity, positive infinity. Okay, but how can we find the vertex? Okay, vertex form, our vertex is pretty easy. Okay, the vertex is, once again, the opposite of the inside value, and then that outside plus minus we keep as is. So we have our vertex here. Okay, now how can we find the vertex in our other two forms? Okay, the way that we find the vertex is a two-step process. Step one is finding the axis of symmetry. Okay, so that's where we need to go back and use that tool, x equals minus b minus 4 over 2 times a, which is 2. So we get a -1 for our axis of symmetry. Now, if I show you the picture of this graph, I don't know exactly what it looks like, but somewhere in here, we've got our axis of symmetry at -1. Since this graph is positive, we know that it's face up, so it looks something like this. Okay, axis of symmetry is part of the vertex. It's the x value of the vertex. So now my vertex is half done. I have the -1 for my x value. Now I just need to know what y is. Okay, so if we have an x, how do we find a y? We just plug and chug. Okay, so we have to plug in our axis of symmetry value, and always be careful of parentheses here, especially when you're squaring a negative number. But we're going to go through and we're going to solve for the y value, and that will finish out our vertex. So -1 squared is 1. We've got 1 times 2 is 2. -1 times 4 is -4, and then a -9. So we have -13 plus 2 gives us a y value of -11. And now we've found the vertex. Remember, step 1, axis of symmetry. Step 2, using the axis of symmetry, plugging it into the original equation to find the vertex. And then in a little bit here, we'll talk about domain and range of these graphs. Once we have our vertex point, that really helps us solidify our range value. Okay, from factored form, once again, finding our axis of symmetry, averaging the two x-intercepts to get our axis of symmetry, -1. Okay, so we have that same axis of symmetry that we had up above. So once we have that situation set, we're going to find our vertex by, once again, plugging the -1 in, solving for our y value. So we always want to understand, one of the most common concepts in math is the plug and chug. We have an equation, we have a function, we have a number that we have to plug into it, and we work through to find our solution. So we have -3 times 2 times -6. So we have negative and negative is a positive. Okay, we have 6 times 6. Okay, we've got a positive 36 here. Okay, so we have a big jump here for the vertex of this point. Okay, and that makes sense based on how spread out those two values are. You know, we're going to have to go up a fair distance here. Okay, now, how do we handle domain and range? So we have the vertex of all of these graphs. So we could look at the quick sketch of the graph. This first one, 7, 1. So 1, 2, 3, 4, 5, 6, 7, up 1. Here's our point. There's the vertex point right there. Since the equation is positive, okay, we've got the nice happy parabola in this situation. It's face up. So now for domain, domain never changes for any parabola. Okay, it is always from negative infinity to infinity. We can plug in x values from one side to the other and they always work. Now our range goes from low to high. So we can see the highest value of this graph is going to be infinity. We need a bracket on the lowest value because it is a graphable point. What is our lowest y value in this situation? The y value of the vertex, which is 1. Okay, same thing for this next graph. Okay, it's a positive graph. The vertex is at negative 1, negative 11, 7, 8, 9, 10, 11. Okay, remember, all we're doing here is quick sketch graphs. Okay, we've got our quick sketch graph. We know that it's face up because we have a positive leading value. Okay, domain never changes. The domain always goes from negative infinity to infinity. The range in this situation, we've got the arrows pointing up, so it's going to go to positive infinity. And then we just need to know what is the lowest possible value for this graph, and it is the negative 11. Okay, now let's look at our last graph here. We've got a negative leading value, so our point here, okay, negative 1, I'm going to have to go 5, 10, 15, 20, 25, 30, 35, and here's my 36 point up here. We know that this graph is face down because of the negative leading value. So now, domain, once again, never changes, from negative infinity to positive infinity. Now our range, the arrows point down, so we know that this graph has the lowest value, starting value of negative infinity, and now it's going up to the maximum y value of 36 for the point. Okay, so that's how we look at domain and range as well. Okay, and then last, just some extra practice of finding the vertex. Okay, we're going to run through these fairly quick here. Okay, finding the vertex of this first one, we're finding our vertex forms first, opposite of x, trust the outside y value. Okay, we've got our vertex point here, opposite of the x, we trust the outside, so we have that point. Okay, and then for our other ones, and I'm only going to do one of each just to save a little time, cut down the time on the video here. What we always have to do is find the axis of symmetry. Okay, so remember, we're finding the AOS first, axis of symmetry. X equals the average of negative 10 plus negative 8. So we've got a negative 9. And then we plug that negative 9 into the function to solve for x. So when we do that, we end up with a negative 1 and a positive 1. So negative 1 times positive 1 is a negative 1 for our vertex. Okay, this graph would be face up, so that would be our lowest value of the range as well. Okay, now looking at our other two, both of these were fraction form, you know, so it's not great, but we've changed this one up to make life a little bit easier. Axis of symmetry, x equals opposite of b over 2a, negative 6 over 3, or a negative 2. The negative 2 is our x value. We're going to plug in and solve for y. negative 2 squared plus 6 times negative 2 minus 8. So we have 4 minus 12 minus 8. So we have a positive 4 and a minus 20. So we have a minus 16 for our vertex point here. That concludes our lesson. Thank you and have a good day.